I've said before, manufacturing documentation, if you think of it like a Lego set, we write the little instruction manual for the Lego set so that anybody can pick that thing up and build the set, you know. And that's a challenging thing to do, because especially when somebody's building something on the floor, 5 different people might interpret an assembly drawing 5 different ways. And it's difficult to anticipate the 5 different ways, but it teaches you to try and define it in such a way that makes it repeatable, makes the assembly process repeatable.
That's one advantage, actually, using a contract manufacturer. When the engineers take a look at the documents when they're designing the manufacturing process, they don't know a lot about your product. So having that, having somebody that understands assembly but isn't familiar with your product, it causes them to ask a lot of questions like, what exactly is this? That's why we go searching for part numbers. When someone says, oh, put the control PC board on the PC on that bracket. Well, exactly which PC board are you calling the control board? Well, an engineer, when there's 5 PC boards in a product, the control board, it's the green one. Yeah, I'm looking at 5 green PC boards, right? 2 of them are small. One of them is gigantic. That's the one, that's the control board. If you wouldn't mind, if you could give it a part number and write the part number on the board, then you can just say, take board 29374, and we can look and say, that is this PC board.
Right.
And it's complete and it's unambiguous. That's a bigger problem than you would think. There are a lot of assembly drawings that don't have part numbers on them. They just point to and call it the control board. Yeah. And now you're kind of comparing PC boards that could superficially look pretty similar to kind of sketches of them on an assembly drawing. It's very easy to get that. It takes a lot of time to dig into the details and say, oh yeah, this is the board they're talking about. So
right.
So we have part numbers, we have descriptions, we have serial number tracking, and all kinds of things that we may have to do that requires that we know with an absolute certainty exactly which part we're talking about. Yeah. So and that's a tough thing to do.
It's interesting. I mean, we've mostly been talking about tangible items, right? Custom parts, custom boards, whatever it may be. It gets another layer of challenge when you've got software that you need to load on, or firmware even. If it's a particular firmware, you need to know with absolute certainty that a certain version of firmware is getting loaded onto the product at a certain time in a certain way, and it's guaranteed to be the right version. And with something that's not as tangible as a part in your hand, you got to have a lot of control. And we do it a lot with our products. There's one product that gets a certain image, a certain software image applied to it, and it's the same image every single product. So we have what we call a master image that we then go and duplicate, and there's a whole process for that allows us to load that software onto each product each time, and we know it's the same and we know what version it is, so that when the product leaves the building and somebody calls us up in 3 months and says, hey, I need this I need this updated, or I need it maintenance on it or something, we have a definition of what it is or what it was when it left here. Softwares and firmware, it's challenging when it's not something tangible that you have to be able to control and define and understand fully what it is and how to get it onto the product.
Right. And it requires proper controls on the versioning of the software. And in general, that happens. It's rare when we see, oh, here's the software and they just give it to you and, well, what's its version? Oh, I don't know. We don't have a version on it. I mean,
The
that's
latest one.
the latest one. That's kind of rare. But we have a documentation control systems, and we can put software images into that documentation control system, just like we could put in a PDF of an actual drawing. It's all electronic. So we have copies in a secure and unambiguous system that if we need to go back and pull version 2.7.3, even though we're really at version 2.7.8, for some reason, if we need to come up with that old version, we can still do it and know exactly what it is that we're putting on a product. So having proper controls on the revisions of the documentation for the product is also key. A bracket might be at Rev A when it's released, but by the time you've built a couple of batches of them, it might be up to Rev C because, well, changes happen. And there's a whole engineering change control process to make sure that we know exactly which bracket is going on which serial number product. And that's the way that you can control it. So when something gets shipped in, a bracket's kind of a trivial example, but a different revision on a printed circuit board could be a lot more subtle. You have to know exactly which PC board is on this product. Oh, it's that board Rev B, but we're currently doing Rev C. And you need to know, can you update it to a Rev C board? Well, an engineering change will describe all of the changes where that product went from B to C to give you an idea of what the changes are and what other changes might need to be made to the product in order to bring it up to the current version. So it's all of that requires part numbers, revisions, bills of material that identify exactly which part and revision are on the product that you want built. And the drawings of the, say, machine parts or brackets that you might need, they have to define the shape, the tolerances, the finish. Is it an anodized bracket or is it iridized, or and how smooth does this surface need to be, because maybe it's a sealing surface and there's an O-ring up against it. So that's why a step file isn't necessarily the right way to define a machined part, because it doesn't really have surface finishes and it doesn't identify what the tolerance is, the allowed tolerance is between, say, two mounting holes. So that's where you need a drawing where you can specify that. There's a lot of, and that drawing also needs to say what the standard tolerance is for everything else in the product. That's usually pretty easy. You just say, oh yeah, use 5,000 tolerances on everything except these holes. They need to be tighter than that, or they can be looser than that to save money. There's a lot of documentation, a lot of details in the design that are important. Our incoming inspection group, when they receive the part, depending upon if this is a brand new part from a brand new supplier, they may do a sampling inspection, and if everything works out, but it'll be a pretty big sample. For parts that, oh yeah, every month we get 100 of these parts in, now maybe we're only looking at one of them because we know that the supplier has it under control. They have a history of sending in good quality parts, and we know that they have the quality system in place to to be very repeatable. I think eventually we can actually get them dock to stock if they've got it under control. And if there's a change to the part, the revision goes up, back into incoming inspection to make sure that the parts that supplier is making meet the intent of our engineering department when they made the change. That kind of closes the loop to make sure that it wasn't a misunderstanding. And misunderstandings happen all the time. It's not a matter of, oh, they did it wrong. Maybe you could argue that the engineers didn't describe it well enough.